look into the architecture of the internet and how does the data reach you. So, have you ever had this question in your mind? If not, at least you get it now, you have it now. So, because I'm going to explain how does the data reach you? How does the YouTube video that you are presently streaming in YouTube or watching in YouTube or viewing in YouTube reach you? How it is reaching you? So the architecture of the internet has also changed a great deal as it has grown explosively. So in this slide, I will attempt to give a brief overview of what it looks like today. So the picture is complicated by continuous upheavals in the business of telephone companies, telcos, cable companies, and ISPs that often make it hard to tell who is doing what. So one driver of these upheavals is telecommunications convergence, in which one network is used for previously different uses. For example, in recently the recent development is a triple play. Triple play. What does the triple play mean? So one company sells you telephony, TV, and internet service. So three services will be sold by one company through one subscription. So that is called triple play. So over the same network connection on the assumption that this will save your money. Consequently, the description given here will be of necessity somewhat simpler than reality, and what's true today may not be true tomorrow. So let's explore and expound the uh, internet architecture or the architecture of the internet. So let's begin with various subnets in America, and then if you look into the America subnet, this is one subnet. So this subnet consists of various routers, and then to transmit a light signal we have optic fiber with a certain standard that could be cat 5. Normally these are called backbone. The optic fiber lines, transmission lines that we use in subnet are known as backbone. So a router and a backbone and together makes it a subnet. So basically, as this is subnet, so we call this as a tier 1 ISP. So if you want to tap in network from here, so that's a tier 1 ISP. The one who provides this service provider are called as a tier 1 ISPs, tier 1 internet service provider, and this is America's subnet. Similarly, Europe has their own subnet, that is again routers and then backbones, and then it makes up one subnet that belongs to Europe. And similarly, China has their own subnet. It makes routers and then transmission lines collectively makes up the China's subnet. Then same goes with India. India has their own subnet and then routers and then transmission lines. And here, if you see, America's internet service provider could be what some other provider, some other enterprise, and here in Europe somebody, in China somebody, in India somebody. It is not same. In India it could be Geo or somebody else, and then in America it could be somebody else. That's what I'm saying. So no, these backbones are these subnets are owned by different service providers, different service providers. The one who is owning uh, the one who's owning the mm, subnet in America is not maybe he is not going to own subnet in India. He can, but we're not sure. Somebody else will have a subnet in India. Okay, so these are the subnets in America, Europe, China, India. Then basically to connect from one subnet to other, we'll use peering at IXP. So it's internet exchange point. So this is called uh, basically until unless if you don't connect one subnet with the other subnet, or one network with the other network, so it's impossible to transfer or transmit data from one network to other network. So that is the reason we connect one network to other through peering at IXP, peering at internet exchange point. So each subnet or each network will be connected through this. You can see America's network with the Europe, America's with the China, America with the China, and then China with the India. So ISP networks may be regional, national, or international in scope. So we have already seen that their architecture is made up of long distance transmission lines that interconnect routers at POPs in different cities that the ISPs serve. So this equipment is called the backbone of the ISP. If a packet is destined for a host served directly by the ISP, that packet is routed over the backbone and delivered to the host. Otherwise, it must be handed over to another ISP. So ISPs connect their networks to exchange traffic at IXPs. These are called internet exchange points. So the connected ISPs are said to peer with each other. So the big picture that is shown in the slide, uh, let us examine this figure. Let's examine this figure piece by piece, starting with a computer through which you are watching the video, most probably from India. Let us consider that you are watching this video from India. So now, to join the internet, the computer is connected to an internet service providers, or simply ISP. So from whom the user purchases internet access or connectivity. So here in this case, the method used to send signals over the cable TV like DSL. So this is a way to reuse existing infrastructure. So in this case, otherwise unused cable TV channels. So the device at the home end is called a cable modem. I think most probably you might have used, I think 2000 kids might have used this one, cable modem and then cable. So the device at the home end is called the cable modem, and the device at the cable head end is called as CMTS, cable modem termination system. Okay, so then, so Geo, Airtel, VI, that's Vodafone Idea, BSNL are top 4 ISPs in India. So by total subscriber base, and Rail Railtel Corporation of India is a state-owned ISP with pan India optic fiber network along railway track. So this is one way of connecting or accessing other networks through internet, that is cable modem, and then the one which we use to connect with the router or to the CMTS, that is cable modem termination system. We call it as a cable. So uh, this lets the computer exchange packets with all of the other accessible hosts on the internet. The user might send packets to surf the web or for any of 1,000 other users, it does not matter. So there are many kinds of internet access, and they are usually distinguished by how much bandwidth they provide and how much they cost. But the most important attribute is connectivity. So now let us look into these various types of internet connectivities that we can have at the present time. So now let us take one example. One of my friend is living in Europe. So this is the guy who's in Europe. His name is Raki or Ramki. So now we'll see what are the ways that he connect an internet. He connect an internet connection to your home, or what are the ways he can connect with their ISP network, that is internet service provider network. So the first one is a common way to connect to an ISP is to use the phone line to your house, in which case your phone company is your ISP. And the second one is DSL. DSL short for digital subscriber line. Digital subscriber line. So DSL reuses the telephone line that connects to your house for digital data transmission. So in this case, the computer, so you can see this, in this case that you will have a DSLAM, this is the main one, and then DSLAM is digital subscriber line access multiplexer. The computer is connected the computer is connected to a device called DSL modem. Here it is, it's a DSL modem, and that converts between digital packets and analog signals that can pass unhindered over the telephone line. At the other end, a device called a DSLAM, Digital Subscriber Line Access Multiplexer, which converts between signals and packets. So this is one type of connection. So in this connection, basically we call it as it's basically the simplest way. Many of the 2000 kids or 2010 at that time, they might have used this widely. It is called you have to take a telephone connection to have a internet. So that's why you take a telephone connection internet. Basically, we are using a telephone line for internet. So at your home, you will have a DSL modem, and then the cable that we get it from DSLAM is known as DSL, and then on the main side we'll have DSLAM. That's a digital subscriber line access multiplexer. So the best examples, the one who provides this kind of DSL based internet service are Century Link, AT&T, Earth Link, Verizon Wireless. So these are the companies. Basically, these are a few examples of DSL internet service providers. So then we will look into another another type of connecting internet to your home, to your laptop. That is dial up. Dial up. So I have one more friend. His name is Krish. He also lives in Europe, and he also wants to connect with he wants to get connection of internet. So how can he do it? So now let's see what way and what method he has chosen. The method he has chosen is dial up. So several other popular ways to connect to an ISP is a higher bandwidth way to use the local telephone line than to send bits over a traditional telephone call instead of a voice conversation. So is called as dial up, and done with a different kind of modem at both ends. The word modem is short for modulator, demodulator, modulator, and demodulator, and refers to any device that converts between digital bits and analog signals. So this is our dial up, and this is our router, and this is the way we connect with the dial up. And then I have one more friend who he also lives in Europe, and he wants to have a connection. He also wants to have a connection, and let's see what kind of connection he will get for his laptop, for an internet connection. So now this time uh, so he has a problem. As thus far we have seen DSL based connection, and then dial up to connect. Two types of connections we have seen. So now DSL and cable provide internet access at rates from a small fraction of a megabyte per second, it's MB per second, to multiple megabit per second. So megabit per second to multiple megabit per second, depending on the system. So these rates are much greater than dial-up rates, so which are limited to 56 kbps. So if you go for the dial-up, it is just 56 kbps because of narrow bandwidth used for the voice calls. So internet access at much greater and dial-up speeds is called the broadband. So the name refers to broader bandwidth that is used for faster networks rather than any particular speed. When they say broadband, it's better than the dial-up. That's it. So now this guy, he has three options. One is through cable, other one is through DSL, other one is to dial up, out of which he, after looking at the speeds, one is broadband, these two are broadband, and then through cable it's a narrow band. After looking at all three options, he wants to go with, he was looking for an option which gives much more broader band network, a much more faster speed, a much more better network. So then he found, this is the guy, then he found a FTTH, that is fiber to the home. So the access methods mentioned so far are limited by the bandwidth of the last mile or last leg of transmission, and by running optical fibers directly to your home, directly to the residences, faster internet access can be provided at rates on the order of 10 to 100 mbps. This I'm talking about only 4G, so it's not 5G. So this design is called the FTTH, fiber to the home. And for business in commercial areas, it may make sense to lease a high speed transmission line from the offices to the nearest ISP, internet service provider. For example, in India, a T3 line capital T3 line runs at roughly 45 Mbps. That's what these were old data. So as now 5G is rolling out, now the things will change a lot. Okay. So that's how from cable, DSL, dial-up fiber, we have seen different types of speeds and different types of networks and various ways of connecting an internet to your laptop or to your home. So now let us look into cellular technology. What is a cellular technology? So a wireless way of connecting to the network is called cellular technology. So wireless is used for internet access too. So the latest technology 5G mobile phone networks. So they can provide data delivery rates at almost 1 Gbps or higher to mobile phones and fixed subscribers in the coverage area. Thanks to the our honorable Prime Minister Modi for rolling out the 5G and is planning to completely roll out the 5G by end of this year. So we are fortunate to have this much of fast faced technological development, and we are fortunate to witness these kind of fast-paced technological developments in India. So I thank him from bottom of my heart. So now let's get back to the topic again. So um, the present and existing technology is 4G. So 4G mobile phone networks can provide data delivery at rates up to 200 Mbps. Normally we maximum get at 100 Mbps, but it can provide up to, the hardware is designed in such a way that it can take up to 200 Mbps speed to mobile phones and fixed subscribers in the coverage area. The old technology was 3G mobile networks, and they can provide data delivery rates. They can provide data deliveries at a rate of 1 Mbps, and one the 3G is maximum 1 Mbps and or a little higher to mobile phones and fixed subscribers in this coverage area. So these are, before that we'll have a 2G, and then before that 1G, but they're not for the data transmission. They are just like digital calls and just for voice transmission. That's it. So 5G is 1 Gbps and more, 4G up to 200 Mbps, and 3G up to 100 MB, sorry 1 Mbps. Okay, these are the different types of generations of network cellular technology that has been developed in India, and as per the Indian government, they'll be starting to work on 6G technology by end of this year. And again, one more time, I thank this present Indian government from my bottom of my heart. So now let's look into ISP network. So we can now move packets between the home and the ISP. So we call the location at which customer packets enter the ISP network for service. The ISPs is known as point of presence, that you can see here. Here it is point of presence, POP. So we will next discuss how packets are moved between point of presence to of different ISPs. From this point on, the system is fully digital and packet switched. So ISP networks may be regional, national, or international in scope. So we have already seen that their architecture is made up of long distance transmission lines that interconnect routers at POP, that point of presence in the different cities that the ISPs serve. So this equipment is called the backbone of the ISP. Just at the beginning of this slide, we have seen that what is backbone, what is router, and what is subnet. So if a packet is destined for a host served directly by the ISP, that the packet is routed over the backbone and delivered to the host. Otherwise, it must be handed over to the another ISP. So now let us look into one more concept in this that's called Internet Exchange Points, IXPs. Here you can see I have gave a brief about ISP before, but now let me explain little bit in depth. So after that we can go for the certain examples of how the data reaches to you. So for internet exchange points, IXPs, ISP, that internet service providers connect their networks to exchange traffic at IXPs, internet exchange points. The connected ISPs are said to peer with each other. There, if you see this example in this slide, this is America's subnet, this is another network. So these two networks are connected through IXP. So basically what this process is called peering at IXP, because one network is basically peering into another network. So that's what we call it. Now here these are drawn vertically because the ISP networks overlap geographically. So basically an IXP is nothing but, you don't think it is something magical, it is just a room full of routers, at least one per ISP. So when I represented appearing at IXP with the dotted lines, you don't think it's something some magical thing is happening here. Nothing. You will have a specific room to that, and we call that as IXP room, and then that's where the backbone of the America subnet and then backbone of the European subnets come, and they will connect it to the common router. That's what we call it as IXP, because that's where these two networks are being peer to each other. So that's what is called as a IXP, internet exchange point. That room itself is called as a IXP. So in this room, a LAN in the room connects all the routers. So packets can be forwarded from any ISP backbone to the any other ISP backbone. It could be regional, or it could be local, or it could be anything from regional America's backbone to the European backbone, America's backbone to the Chinese backbone, Chinese backbone to the India's backbone. So IXPs can be large and independently owned facilities. So one of the largest is the Amsterdam Internet Exchange Point. You just Google it, Amsterdam Internet Exchange Point. So you will get it the complete information about that. Basically at Amsterdam Internet Exchange Point, hundreds of ISPs connect, and through which they exchange hundreds of gigabits, not gigabytes of gigabytes per second for traffic. That much of traffic will be there at the Amsterdam Internet Exchange Point, the one of the busiest internet exchange point is the Amsterdam Internet Exchange Point. Just Google it and do a bit of more research on that. Then we will look into a relationship between ISPs, how the ISPs can connect, and on what basis, whether it is financial basis or monetary basis or mutual understanding. So on what basis one backbone from the America and other backbone from the Europe can be connected. So that's what we are going to look now, because that is also very important aspect. So the peering that happens at IXPs depend on the business relationships between ISPs, internet service providers. For example, a small ISP might pay a larger ISP for the internet connectivity to reach distant hosts. much as a customer purchases a service from an internet provider. So in this case, a small ISP is set to pay for transit. It's a proper way of putting this is pay for transit. Alternatively, two large ISPs might decide to exchange traffic so that each ISP can deliver some traffic to other ISPs without having to pay for transit. So, one of the many paradoxes of internet is that ISPs who publicly compete with one another for customers often privately cooperate to do peering, because without the coordination and without the cooperation it's very difficult to create a complete network across the globe. As I just said, one of the many paradoxes of internet is that ISPs who publicly compete with one another for customers often privately cooperate to do peering, because that's very important, or else it's very difficult to connect with another backbone in another region, or so that's very difficult. So the cooperation is very much required between different ISPs. Either you can pay for transit, or you can have a mutual cooperation and understanding without financial terms. So let's then after that, the path the path a packet takes through the internet depends on the peering choices of the ISPs. If the ISP is delivering a packet peers with the destination ISP, it might deliver the packet directly to its peer. Otherwise, it might route the packet to the nearest place at which it connects to a paid transit provider, so that the provider can deliver the packet. So, two example paths across ISPs are drawn in the above slide. Often, the path a packet takes will not be the shortest path through the internet. So it can take a longest path, or it can take a shortest path. So if data should be sent from America's backbone to the China's, either it can take this peering point or this peering points. Anyone it can take. So now let us look into the one more concept called uh, Tier 1 ISPs, Tier 1 Internet Service Providers. At the top of the food chain are a small handful companies like AT&T, AT&T and Sprint. 33 operate large international backbone networks with thousands of routers connected by very high bandwidth fiber optic links. These ISPs do not pay for transit. They are usually called Tier 1 ISPs and are said to form backbone of the internet, since everyone else must connect to them to be able to reach to the entire internet or entire globe or entire world. So now let us look into the most important concept in getting a data from somewhere. Basically, now years after we have gone through the each and every component of internet architecture, and now we are going to look into how does the data reach you. But to to understand the data, to understand the principle behind the data reaching you, you must understand one important concept that is called data centers. Companies that provide lots of content such as YouTube, WordPress, Ghana, Netflix, Google, and Yahoo locate their computers in data centers that are well connected to the rest of the internet. These data centers are designed for computers, not humans, and may be filled with rack upon rack, rack upon rack, rack upon rack of machines called a server farm. A server farm, like agricultural farm, a server farm. So, co-location or hosting data centers let customers put equipment such as servers at ISP POPs, at ISP presence of points, so that short, fast connections can be made between the servers and ISP backbones. So the internet hosting industry has become increasingly virtualized, so that it is now common to rent a virtual machine that is run on a server farm instead of installing a physical computer. So these data centers are so large, tens or hundreds of thousands of machines that these data centers consists of, and these data centers are large, that electricity is a major cost. So data centers are sometimes built in areas where electricity is cheap and where the climate temperature doesn't go too high, and where the temperatures are a bit of low, so that the cooling expenses for your system is also lesser. So now let's move on to, so we have, by and large, we have seen all the concepts that are related to the internet architecture. Now it's time to take a few examples to understand how does the data reach you, how data reaches you. So this ends our quick tour of the internet. Now we will discuss two examples that demonstrates how data flows from a data center to your YouTube on your mobile and laptop, and how each mobile phone communicates with each other. So presently you might be watching my video in YouTube either from your mobile or from your laptop. So that's why I've taken two examples how my video reaches you, either from mobile, either in mobile or laptop. So one one point I just want to put forward, and worth mentioning here, is that what it means to be on the internet is changing. It used to be that a machine was on the internet if it ran the TCP or IP protocol stack and had an IP address and could send IP packets to all other machines on the internet. However, ISPs, Internet Service Providers, often reuse IP addresses depending on which computers are in use at that moment, and home networks often share one IP address between multiple computers. So this practice undermines the second condition. So security measures such as firewalls can also partly block computers from receiving packets, undermining the third condition. So despite these difficulties, it makes sense to regard such machines as being on the internet while they are connected to their ISPs. So also worth mentioning in passing is that some companies have interconnected all their existing internal networks, often using the same technology as the internet. So these intranets, basically, if they are interconnected in the internal networks, these are called intranet networks, are typically accessible only on company premises or from company notebooks, but otherwise work the same way as the internetwork. So first, let us look into an example where a YouTube video from data center till reaches you you at your laptop, which is connected through fiber. So here the end point, here the end data transmission or last leg or last mile data transmission is FTTH. That is this fiber to the home. Okay, let's see this example. So my video has been hosted in a server which is located in um, which is located in Silicon Valley of United States of America. So from there, when you request, when a guy from who's sitting in Europe, he requests for a video, my YouTube channel, then that from the server it passes through in bits, and then after the bits will be converted into the light signal, analog signal. So the digital signal will be converted into analog signal, and it will enter into the router, because this is also optic fiber, and then from the router it goes to the another line. It could be a backbone, and then from there it will enter into the at the peering point. Through the peering point it will enter into the subnet of the America, of any tier 1 ISP, tier 1 internet service provider. From there there will be one more peering point, one more IXP, internet exchange point, and then through that internet exchange point, a room router, it will enter into the subnet of Europe. And then from there it will go to the backbone, from that backbone to the nearest router to your home, and from there through the optic fiber it will directly come to your laptop, because as it is connected to the optic fiber, it will directly come through the optic fiber and it will enter into your laptop. And from there you can able to see the video that I have hosted in in a server which is located in Silicon Valley of United States of America. So this is the first example. So now let us look into a second example. In the second example, where same YouTube video is hosted in a data center which is located in Silicon Valley of America, and then so that should go to the one who's residing in China, and who wants to watch that in mobile phone. So it's like YouTube video streaming from data center till YouTube on a mobile, on a Chinese personal mobile phone which is connected through the cellular network. This is the second case. Let's see how it works. So YouTube video is converted into analog signal, a light signal through the optic fiber. It has entered into the nearest router, and from the router into the backbone, and then into the subnet. From the subnet it will find a path, it will find the best path. We cannot say shortest path, it will find a path, and then it will find the IXP, internet exchange point, with the Chinese subnet or Chinese network, and then through that internet exchange point it will enter into the Chinese subnet, and then from the Chinese subnet router it will go into the backbone of the Chinese subnet, and then from the nearest router through the optic fiber cable it will find nearest antenna. So sorry, nearest nearest cell tower, and then the cell tower consists of a transmitter, and that transmitter will base that transmitter will once it reaches to the cell tower consists of a transmitter, and that transmitter will emit network signal. Basically these are radio waves, electromagnetic radiation or electromagnetic waves, and these waves will propagate inside the propagate around, and then it will find out the receiver. It will find out the network, basically based on which operator, based on the SIM card operator, based on the SIM card operator and SIM card operator location, it will directly go to that mobile phone. That mobile phone will have a receiver, and then that receives, and that guy will able to watch my video in his mobile phone YouTube application.